All right, let's dive into one of the most fascinating shifts happening in blockchain right now. We're talking about the move away from totally public ledgers and towards something new: programmable privacy. Today, we're going to break down the Midnight Network and see how it's poised to change, well, pretty much everything.
So let's kick things off with a little thought experiment. How do you prove something is true without actually giving away the secret? I mean, really think about that. This one puzzle is right at the heart of our discussion, and the solution, zero-knowledge proofs, is an absolute game changer.
But hey, before we can get to where we're going, we've got to understand where we've been. So let's take a quick look at a crucial piece of the puzzle: the evolution of smart contracts.
This timeline really tells the story, doesn't it? Back in 2009, Bitcoin script was our starting point. Super simple, pretty secure, but you couldn't do a whole lot with it. Then, boom, 2015, Ethereum Solidity comes along and just blows the doors open. Suddenly we could build these complex dApps, but that flexibility came with its fair share of bugs. So in 2021, Cardano's Plutus came in with a laser focus on security and formal verification. And just recently, Icon has made building on Cardano even leaner and more efficient. You can see the trend, right? Every single step is a push towards more power, but more importantly, way more security.
And that's the perfect lead-in to Cardano's secure foundation. Because honestly, to really get what makes Midnight so special, you first have to appreciate the incredibly secure and unique base that it's built on top of.
So a key concept here is something called the Unspent Transaction Output Model, or UTXO for short. Now, I know that sounds super technical, but the analogy for it is just brilliant. Imagine the blockchain's outputs are just a bunch of post-it notes on a wall. A transaction, it's just a simple instruction telling the network, hey, take these specific notes down and pin these new ones up. That's it.
And this picture really drives the point home. This whole post-it note system is so powerful because it means the outcome of every single transaction is totally predictable. You can check it and know exactly what's going to happen before it even touches the network. This predictability is the bedrock of Cardano security, and it's the solid ground that Midnight is building on.
Okay, so we've got security and predictability handled. What's the next big mountain to climb for blockchain? Well, without a doubt, the next frontier is privacy.
And here's the thing you have to remember. On most blockchains today, your history is basically an open book. Every single transaction, every interaction, it's all out there for anyone and everyone to see. And for a ton of real-world uses, especially in business or finance, that level of transparency is just a total deal breaker.
This is exactly where the Midnight Network comes into play. It's a blockchain that was designed from day one with privacy at its core. The key phrase you want to remember here is programmable data protection. It uses those zero-knowledge proofs we talked about to let you prove things about your data without ever having to show the data itself. This isn't just an improvement, it's a complete paradigm shift.
Okay, so Midnight is the what. Now let's get into the how. How do developers actually go about building these private apps? The answer is a brand new programming language called Compact. You can think of it as the ultimate privacy toolkit for the Midnight Network. And let's be really clear about the problem they're solving here. Writing code that uses zero-knowledge proofs has historically been ridiculously hard. I mean, we're talking about needing a PhD in cryptography just to get your foot in the door. That has been a massive wall blocking wider adoption. This is why Compact is such a huge deal. It was designed to be the TypeScript for ZK. Now, for any developers out there, that analogy should make perfect sense. It takes something mind-bendingly complex and wraps it up in a language that feels familiar and easy to use. It handles all that crazy hard cryptography for you, under the hood. And when you put them side by side, the difference is just night and day. With something like Solidity, everything is public by default. Every single node in the world has to rerun your whole transaction, and that gets really expensive fast. With Compact on Midnight, it's the total opposite. It's private by default. All the heavy lifting, the computation, happens on your local machine to create a tiny proof. The network just has to do a super cheap, super fast verification. This is a massive win for both privacy and for scaling. So, how does Compact actually pull this off? Well, it all boils down to a new way of thinking about how public and private information can live together on a blockchain.
So first, you've got the ledger. This is the part that everyone can see, the public state that lives right on the blockchain. But, and this is the key, it might not be raw data. It might be something like an encrypted balance or a special kind of hash that just proves something happened without revealing any of the juicy details.
Then you have the witness. This is the magic ingredient. This is all your private stuff that never, ever leaves your own computer. We're talking about your actual bank balance, who you voted for, your personal info, all the secrets you want to prove something about without revealing. And finally, you have the circuit. The circuit is the logic that acts as the bridge between the public and private worlds. It's a bit of code that runs locally on your machine. It takes your private witness data and it cooks up a cryptographic proof that can then interact with the public ledger. So the network gets to see the proof, but it never ever sees your private data. Now, when you put all these pieces together, the ledger, the witness, and the circuit, it completely opens the door to a whole new era for decentralized applications and what they can actually do.
Let's make this real with a simple example, a private bulletin board. In the old world, using a language like Solidity, if you post a message, your wallet address is stuck to that message forever, publicly. But in the new world with Compact, you can prove you're an authorized member of the group and post a message, and nobody will ever know which member posted it. The network just confirms, yep, a valid member posted this, not that Bob posted this. Think about what that means for things like anonymous feedback or private social groups. It's huge.
And what's really cool is that they've made the whole process for developers seem pretty straightforward. You just write your logic in Compact, run the compiler, which spits out all the complex ZK circuits and on-chain code for you, and then you deploy it. The whole point is to bring this incredible power to way more developers than ever before.
So that really leaves us with this final, massive question. What becomes possible when privacy isn't just an add-on or an afterthought, but it's baked into the very foundation of the system? We're talking secure digital ID, private finance, confidential data for businesses. Honestly, we're just scratching the surface of what this unlocks.